Yeah, so let's begin. Cool. Yeah, welcome guys to Pi&AI Break into AI. We will. So I'm Ayushman Kumar, an open source contributor at Tensorflow and founder of the Open Source Society. Firstly, I would like to thank DeepLearning.AI for their support in today's talk, and let's just begin. So first we have a message from the AI guru Andrew Nung and DeepLearning.AI. So they have a video to show us. So let me just play the video for you all.
Hello, deep learners. I'm Andrew Ng, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pi&AI what you do at DeepLearning.AI?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There is never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pi&AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, and that's really important work. Well, it's nice chatting, and now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pi&AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.AI, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pi&AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the DeepLearning.AI community.
So yeah, that was a message from Andrew Nung and the DeepLearning.AI team. So yeah, so finally a warm welcome to everyone and thank you for coming out today for attending this session. I'll try to keep this session as short as possible, and I'll try to keep this session to the simpler side. Cool. So let's begin. So our agenda for today, we'll start by looking at what is TensorFlow. Then we'll see that why should we use TensorFlow over any other framework. Then we will go through the very basics of neural networks. Then we visualize how neural network using the TensorFlow Playground. Then we will see that how can you can translate this basic neural network into a TensorFlow or Keras code. Then we will see how to work with Keras models and layers. Then we will see some practical demonstrations of mainly regression models and classification models using neural networks. And then we will see something known as the teachable machines. So that is a very cool website by TensorFlow that demonstrates few cool applications of machine learning. We will see that later in this talk. So yeah, moving on. So the first question is, what is TensorFlow? Cool. So TensorFlow is an end-to-end open source platform for machine learning. So what makes it unique is that this term end-to-end. So what is an end-to-end? You see, so this is the whole machine learning pipeline that we followed while working on any project, right? So it starts with gathering the data, then we perform our EDA, we prepare our data, and then we build our models, train it, evaluate them, tune our hyperparameters, and then then update our hyperparameters, and then just put this process into the loop. And then after we get our optimal neural network, we then put it into deployment. So TensorFlow enables you to do all these things through their libraries. Cool. So yeah, so that makes TensorFlow unique from any other framework. Yeah. So yeah. So what we will look today is that we will look at the Keras API on TensorFlow. Okay, so see, so TensorFlow's high-level API are based on Keras API standards for defining and training neural networks. Keras enables fast prototyping, state-of-the-art research and production with all user-friendly APIs. We will see what this is. Okay, so yeah. So another question is, why should we use TensorFlow? So the very first point to this is that it's supported by the great Google. Cool. Yeah. And second, it's open source. And yeah, it is one of the most popular machine learning library on GitHub. Cool. And now this the fourth point, that you can use machine learning on web, Android, and even low-power devices like Raspberry Pi, which makes it very unique from any other machine learning framework. Right? TensorFlow provides you like TensorFlow.js, a JavaScript library for JavaScript for machine learning on with JavaScript to perform your machine learning on web. It provides you TF Lite, with which you can perform your machine learning task on Android and Raspberry Pi too. And lastly, it's an end-to-end platform for all your machine learning applications. Okay, now let's see that what people around us are doing with TensorFlow. Here's a small video from TensorFlow team, like to show that how it's being used, how these simple models can be used, and in this solving these big problems, the real world problems. Let's have a look at this video.
Médecins Sans Frontières is providing care in 70 countries. Each time we go in a new country, in a war zone, we discover more and more patients infected with multi-drug resistant bacteria. They're arriving with the wrong antibiotics given to them. Antibiotic resistance is everywhere. If we don't act today, we'll have 10 million deaths per year by 2050. Once you identify that there is a bacteria, you do multiple tests to know which type of bacteria it is, And then you test the sensitivity of several antibiotics in order to identify the most effective one. There is an additional step that is the interpretation of those results. In the majority of the countries where we work, there is a lack of microbiologists and human resources to do this interpretation step.
Anwar, he is 10-year-old and his injury was a bullet. It exploded inside his leg. He has very resistant type of infection. We are the last hope for Anwar.
I thought AI might be one of the solutions to this problem.
We developed an application to help lab technicians to interpret the results of diagnosis tests only using their mobile phones. We're using Tensorflow, computer vision, and machine learning to detect interactions happening between the bacteria and antibiotics based on an uploaded image of the petri dish. Our goal is not to replace the lab technicians. The app is really meant to support them in doing their diagnosis test, whilst always keeping a human in the loop. We managed to train a model within a matter of days using Keras and 15,000 anonymized pictures of diagnosis tests. The API was super expressive and it was surprisingly really quick and easy to achieve. We are deploying the app using TensorFlow Lite so it can be used offline on any range of mobile devices in all of our clinics.
Today we have a prototype. We've got a responsibility to make the diagnostic test available, easy, affordable, all over the world. I'm excited because for me this application can be a game changer that's going to help millions and millions of people.
For Anwar, there is one antibiotic suitable for this infection. I think this app, it will solve many problems everywhere in the world.
Yeah, so it was a really cool video. Like it motivated me a lot to use TensorFlow in in medical field too. Yeah, so yeah, it is really motivational because the things that you are learning today. You these such a big these big problems can be solved by what we learn today. So yeah, the field of AI is really helpful for everyone, for this society. And just by looking at this video we can see that how these important issues like the issue that we are facing right now, that can also have an AI alternative, you see. But for discovering the drugs, or discovering the vaccines for the COVID-19 pandemic that we are facing right now. So let's continue with our session. So yeah, so these are few companies which uses TensorFlow in daily basis. Okay. So yeah. So as I said that these are steps to solve a machine learning problem. So in this problem today we are going to look at particularly this, and if possible we will also look into like how to tune the hyperparameters. I'll also show you if I have time, then I'll definitely show you this. Fine. So today we will build a neural network, we will train it, we will evaluate our models, then and then if possible I'll also do some hyperparameter tunings, and then I'll try to explain you the whole code and how to make these things simpler and simpler. Cool. Okay, so let's move on. Okay, so this is a brief about the basics of neural network, right? So okay, so this is something known as a neural network, which is inspired by a human brain. Cool. So for people who don't know what neural network is, here is just about neural network. So neural networks consists of three main layers. So it has an input layer, it has an output layer, and it has something called a hidden layer. Okay, so yeah, so these columns are known as layers, and these circles, these are known as neurons. And as we know that in our brain how the neurons are connected with each other, so these neurons are also connected with each other. Okay, and yeah, so just some maths behind these neurons. Like you see, you are seeing that this particular neuron is getting connected with every other neuron from the previous layer. Yeah, so what actually happens is that, suppose the all the information coming from this particular neuron, or received by this particular neuron, s- uh, is like x. Cool. So suppose if we have x, suppose it is getting 3 inputs. So let's consider we have 3x, suppose x1, x2, x3. So what happens in a neuron is that we get our x1, x2, x3, and then you multiply our x1 with w1, x2 with w2, and x3 with w3, and then we add them all. And after adding them all, we add a particular bias to this. And after achieving this whole thing, like the input times bias and input times weight, and then adding a bias, then we pass it through an activation function. Okay, so after passing this through an activation function, we get the result of a particular neuron. So how this particular thing is done is that we have the inputs, we know the results, we put our inputs here, we get our outputs from here, and and these particular neurons learn the logic behind the inputs and the outputs, and they correspondingly train itself to learn the weights and the biases. Cool. So in the whole training procedure, this is all what the neural network does. It has weights in between the connections. It trains the weights. It learns the weights that it has to have to obtain the particular output for a particular input. I know it's going to too technical, but yeah, let's dive into the practical thing. Okay, now let's TensorFlow provides us something known as a TensorFlow Playground, which helps us visualize neural networks, and let's have a look at it. Okay. So this is called this is the TensorFlow Playground, where you can play with a neural network. You have all the activation functions, the learning rate, and all the hyperparameters. Okay, now you can have this is a particular, this is, suppose this is the input layer, this is the hidden layers, and this is the particular output layer. Suppose we have here two classes, right? So what we can do is that we can choose our number of hidden layers, we can choose our neurons, number of neurons in a particular layer, and then just we can run this particular training step. So you see, with time it's getting trained. You see, it's taking time to just this is a classification model, and you see with time how does this classification task takes place. Now suppose if in suppose it in 76 epochs we are attaining this particular result, right? Suppose if we change our activation function to ReLU, let's see what the results are. See, we are attaining this particular result in less than what we attained with tan-h activation function. So you see that the changing the activation function can really help. So these are kind of hyperparameter tuning that we can do to faster our process and to consume less resources. Suppose if we for now, suppose let me change the learning rate to from 0.03 to 0.1, and now let's see what happens. See, now it takes only 7 epochs to attain what we need, right? So you see that by tuning these hyperparameters, we can make our process more and more easier for us to do. Cool. So yeah, you can I'll share this PPT with you all, and you can go here, you can play with all the hyperparameters. You have multiple tasks here. You can perform any type of regression or classification task. You can play with the training tests, the you can play with the test size data, and you can play with the noise, batch sizes, learning rate, activation, regularization, and stuffs. Cool. So let's move on. So moving on to our next slide. Now this is something very useful from the TF.Keras point of view. So this is the neural network that I showed you in the previous slide. So these columns are known as layers. Cool. So in tf.keras or TensorFlow or Keras, it's known as a dense layer. So every column is a dense layer, and every unit is called every neuron is called a unit. I'm sorry, every neuron is called a unit. So suppose this input layer has 3 units, the hidden layer has 4 units, and the output layer has 2 units. So yeah, that is the thing. So the columns are known as dense layer, and every neuron is known as unit. Cool. So suppose we have 3 input layers, 3 input units. We have 2 input output units here, and so let's have a look here. So suppose we have 2 output neurons, and suppose consider this as a classification task. So the number of output units is actually the number of classes your training set has. For instance, here we can have 2 classes. So we have 2 output units here. Particularly this is a binary classification. Okay, moving on. So yeah, so building a neural network with tf.keras. So yeah, so the steps to build a neural network with tf.keras, we have to follow 2 steps. First, we need to select our model, and then in that model we need to specify our layers to be used. Cool. So tf.keras provides us 3 kinds of models. They are first sequential model, the second is the functional API, and the third is the subclassing API. So this is the level of hardness. So the easiest one is the sequential API, and that is something that we'll be looking today. And the subclassing API is being used by researchers because it gives you more control over your models and all the mathematics that goes behind it. So yeah, so today we'll look at the sequential API. So once we are done with choosing our models, so for here we are choosing the sequential API. So once we are done with choosing our models, we will go and choose our layers. Cool. So in the previous layer slide, I showed you that I'm using the dense layer. So you have many kinds of layers here. Namely, we have dense layer, we have a convolution 2D, max pooling 2D. They are used in convolution neural networks in image processing tasks. We have LSTM, simple RNN, which are used in sequence modeling task. We have batch normalization, embedding layers. These are actually some of the tasks that you can do, to increase your accuracy or model performance. And there are many more layers. You can find them in Tensorflow.org or Keras.io. So let's move on. Let's look at the the code. So earlier I just forgot to tell that to call the models API, you just need to call that tf.keras.models and then the model name. For instance, here we are taking sequential, so it will be like tf.keras.models.sequential. And correspondingly, if you want to call any layer from here, then you can call it like tf.keras.layers. And the model name, that for instance here we will take dense. Cool. So yeah, let's move into the code. So this is the whole building of the neural network. The first, as I said, that first is to select the model that you want to use. So here I'm using the sequential model. So this is a step 1. So I'll make an object of the sequential model, which is like tf.keras.models.sequential. So I make a model object from here, and then we add our layers to this model. So to add layers to this model, we need to do that model.add and tf.keras.layers.dense. Cool. So we are adding a dense layer here with our unit is equal to 10. That means our dense layer is having 10 neurons or 10 units. Cool. And it has an activation function of ReLU. That means every inputs that comes into the neural network, that will pass through this activation function. So the results of all the weights and the inputs with the bias will pass through an activation function known as ReLU. For people who don't know ReLU, ReLU is an activation function which omits every negative results. For instance, if you get a negative output, then it will consider it to be 0. And if it's positive, it will keep it the number it is. Okay, so yeah, so our first layer is a dense layer with 10 units. Our second layer is a dense layer with 1 unit. So it's particular. So we are done with our model building process. So we have a sequential model with 10 layers, 10 units in the first layer and 1 unit in the final layer. So we have 1 unit as our output. So particularly if you look at this model, if you have one, we can consider this as a regression task. You see, now once we are done with um, uh, building our model, we need to compile our model. So for compiling our model, we use model.compile, and then we choose our loss functions and our optimizers, and we can also take in matrices, but that's optional. So as I said that this is a regression task, so I am using MSE or mean squared error, and I'm choosing optimizer as Adam. For people don't know Adam, it's comparable to optimization algorithms like gradient descent. Adam is a better optimization algorithm, so I'm using Adam. So yeah, so once we compile our model, now we'll come to step 4, that is fitting our model. So we'll fitting our model, that is training our model. So for training our model, we give our input, that is x train, output as y train, and we will provide our epochs. So for how many times we need to train this particular neural network. For people who don't know what epoch is, I mean, you can I don't think you can relate to this meme, but yeah, this actually tells that what is the significance of epoch in machine learning. Yeah, so so in machine learning, the number of epochs you put, the model gets better and better until it reaches a particular time, after which it is just overfitting, or it makes no sense. So what necessarily epoch is, that you continuously do a particular task again and again, and in every step what you do, you better yourself. Cool. Now let's dive into the demonstration of this particular code. Sorry. So yeah. So yeah, for this demonstration, I'm using a Colab. So Colab is an online Jupyter notebook which also provides us GPU and TPU support. But for this session, we don't need any GPU. So yeah, I'm not using any GPU. I'm running this whole thing in a CPU, right? For if you want to see that which GPU it provides Tesla P4. Which actually costs around 2.2k US dollars. That's very costly, and it's a 8 GB GPU. Cool. Now let's dive into the code. So yeah, so okay, before diving into code, I would like to know that if you have any questions till now, you can ask me those questions. Okay, I assume that it's going fine till now. Okay, then let's continue. Okay, so first I'll import all the necessary libraries here. So first I'll import TensorFlow as TF. We will import NumPy, and we will import matplotlib. So let me do it. So I'm making here a toy dataset, which is basically an equation y equal to 2x plus 6 with some noise. Cool. So we take our x as I from 0 to 60, and we take our output y as 2 into that particular 2 into I plus 6 and plus some random noise between -10 to 10, and we then we just plot our model here, and we can see our data. It's slightly linear, but it has a lot of noise here. So our task here is to perform a regression task, a linear regression using a neural network. Cool. So yeah, so we start with our first operation, that is choosing our neural network model. That is here we are choosing sequential model. Now we add these two layers to our neural network. Cool. Now as we add our layers to the neural network, then we need to compile our model. So as we are done with the compilation, it's the same neural network that I showed you in the slides. Now I'll run this neural network for 500 epochs. We have all the x and y, which is basically this particular data, and let me run this this training process. It might take some time, maybe a few seconds or so. So you can see that how with every epoch how the loss function is getting lowered and lowered. So it gives us a sign that the neural network is training. So it's taking some time. Okay, so we are done with the final with our training process, and we have the final loss as 338 point something. So let's just plot our our prediction. So here I am plotting the previous x and y, and then I'm plotting x with the model dot predict that particular training set. So we can see that we are getting a really nice model. We are getting a perfect best fit line, and yeah, that was pretty much. And we now we can see at the training process. You see, now this is the plot between the of epochs against loss. Now we can see that how loss is getting lowered with the epoch, and then what happens is that after the 100 or 20th epoch, it's remaining the same. That means that we are wasting the resources, and what we can do is that just lower our epochs. Then we can just train it for say 150 epochs, and our line will be pretty much the same. Okay, so this is a small hyperparameter tuning that you can do, that you can just change the epoch, and and you can achieve the same result, like pretty much the same. Cool. And that was it for the regression task. Now let's get back to our slide. Cool. So yeah, so now we come to the classification task. So how regression in neural network, how regression task is different from a classification task, right? So it's so we have two kinds of differences that we have. Okay, the first is that let's look at the final layer of the classification task. Suppose we have 10 classes. For let's consider the MNIST data set where we have digit from 0 to 9. Okay, so we have 10 classes from 0 to 9. So we need to keep our final unit as 10, because we have 10 classes, and we need to keep our activation function as softmax. If you remember that in the regression task, we did not have any activation function in the final layer, but in classification task we need to keep one activation function in the final layer. So it's like so it's same, it's model.add tf.keras.layers.dense, and then the number of units, that is number of classes that we have, and then the activation. Okay, so here we are using softmax, which necessarily gives us the probability of every class we have. Cool. Now, then we compile our model. So in a classification task, we generally use our loss function as sparse categorical cross entropy, which is necessarily a loss function, which if your answer is same, if suppose the y hat, that is the predicted y and the original y, is right, then the loss is necessarily close to 0, and if it's not right, then the loss function is like infinity. Yeah, and what necessarily happens is that you get something like log of 1, that is necessarily infinity. Okay, log of 0, I guess. Okay, okay, let's continue. Okay, fine. Okay, now suppose we have two classes, right? Now what we can do is that you will be you will see that when we have two classes, I'm just taking one unit in the final layer, and I'm just changing my activation function to sigmoid. Okay, so why are we putting one unit here and why are we putting 10 units here? Can't we put one unit here also? So the answer to that is no. But when you have two classes, then it's better to just put one unit, because if sigmoid activation is computationally less expensive than softmax activation function, and with sigmoid activation function you can pretty much solve this binary classification thing, because you see two classes is binary classification. So what sigmoid activation does is that it takes the input and scale it between 0 and 1. So suppose it's so if it's between 0 and 1, then you can do it like if it's greater than 0.5, then you can consider it as 1. If it's less than 0.5, then it's 0. So that can be done, right? So now so our final layer will have one dense unit and an activation function of sigmoid. Now then we will compile our model and we will put our loss as binary cross entropy, because see, we have two classes, so we can use binary cross entropy and the optimizer will be the same. Cool. So that's it for the classification task. Now let's dive into our code. Let me open. So yeah, let me connect my So yeah, our session is loaded. So yeah, the first few steps are pretty much same. We are just importing TensorFlow, SDF, NumPy, SNP, and Matplotlib as PLT. Now we are just using Keras datasets, and we are importing the MNIST dataset, which is necessarily handwritten dataset of 60,000 training examples and 10,000 test examples, and the size of every image here is 28 cross 28. It's a pretty much it's very famous dataset that we use while getting started with machine learning. So yeah. So what I do is that just load the data and put it in a xtrain, ytrain, and xtest, ytest, and I just normalize my xtrain by 255, because every pixel here is a number between 0 and 255, and when we normalize our data set, it does that it makes our training more efficient. There is some mathematical proof behind it. Let's not get into that. So yeah, so let me just import my necessary libraries and the dataset. So yeah, our dataset is downloaded, and these steps are done. So let's print our xtrain and xtest shape, which is 60,000 training examples with 28 cross 28 as our dimensions, and our xtest is having 10,000 test cases, and we have 28 cross 28, the same example. So let's look at our one of the examples. Suppose here it's 0. Okay, so let's so you see the y train here, y train is 0, and x train we plotted it as 0. So yeah, it's 0. So this is our data. So here what I'm doing is that I'm first selecting my sequential model. Here instead of model.add, I'm just passing the all the layers as a list here. So just what happens is that you have two options. You can either go you and use model.add and add every layer, and else you can do is that you can make a list of these layers and then just pass it into the sequential model. So yeah, what we do is that we take this data, this 28 cross 28 image, then we just flatten it. So what we get out of it is a 28 wait okay wait a second. Yeah, so so we take this 28 cross 28 image, and then what we do is that flatten this out. That means what we will get out of this is that every single layer will be flattened. Like this particular row will be a column, and then this particular row will go beneath this, and then you will get a a shape which is like 28 into 28 comma 1. That is I guess 784 cross 1. That will be the shape of the output of this flattened layer. Okay, now okay, so it will be like 784 comma 1. So we have now 784 comma 1 inputs, and now we put a dense layer with 128 units. So you see these 128, these units are just these are hyperparameters. You can tune it, you can keep this, and you can test it like using 256 or any other number like 32 or something, and you might get different results, you might get better results. So I'm just keeping it as 128. So we add a dense layer, so it has 128 units and an activation of ReLU. Then we add our dropout layer. Dropout is just just a regularization parameter. We don't need to get into that. Just it, what it does, it is that it cancel out all the necessary, unnecessary neurons, and it just takes it takes all the important neurons into consideration while performing the training process. Cool. And then we have our dense layer with 10 units, because we have 10 classes from 0 to 9, and our activation here is softmax. We compile our model with our optimizer as Adam, our loss function as sparse categorical cross entropy, and our matrix as accuracy. So we can we see our how accurate our model is. We can see the performance of our model by taking into consideration the accuracy of our model. We can also do one thing. We can just see our model.summary, which is that's 28 cross 28 is now none comma 784. Then it goes then we have the dense layer. We have this many parameters, which is necessarily the multiplication of these two numbers, I guess, 128 cross this, and then we have our dropout, and then we have our dense layer. Cool. Okay, so so our model is defined. We have a sequential model. We have all the layers inside the sequential model. We compiled our model. We specified our optimizers, our loss function, and our matrices. We saw the model summary. Now it comes to training the model. So while training the model, I'm taking into consideration X train and Y train, and I'm training it for 5 epochs. Then we use then we just evaluate our models to see our loss and the accuracy of our model. Let's let me just train this model. So you'll see that the accuracy goes higher and higher with every epoch I train, and our loss function will decrease with time. So yeah, this is our trained model where we have a final accuracy as 97%, and our loss function is loss is 0.07, which is pretty much good, which is really good. And yeah, so let's predict our thing. So yeah, suppose we have X test, and suppose we are taking the sixth training set from the test model. Cool. Now we take our sixth example from our test set, and we are just printing out what pred is. So what we get is this. This is a list of 10 numbers. This is necessarily the 10 output units that we specified in our neural network. This is particularly this. Cool. So we have 10 output units, which provides us 10 discrete numbers. Cool. Now what we do is we perform an np.argmax. What argmax does is that it provides us the position where where we have the maximum numbers out of a list. So here we have our maximum number at the fourth index, that is 0 1 2 3 4, which is this. So it provides us an answer as 4. Now let's see what our y test at 6 is. So it's also 4. See, suppose if I like, for instance, if I take 7, and now let's see our in argmax, it's 9. Let's see our y test. You see it's 9. So yeah, so our model is working pretty fine. So yeah, it's so it has a 97% accuracy. That means it has 3% chances of getting wrong. Cool. Yeah. So now let's do something. Let's consider this same data set, and now what I will do is that instead of taking our classes from 0 to 9, I'll do something that what I'll do is that if the number is less than 5, that is if it's like 0 1 2 3 4, then I will make that particular number 0, else I will make that particular number 1. So this makes our data set a binary classification problem. So we necessarily have binary digits, that is 0 and 1, instead of numbers from 0 to 9. So you see here we have two classes, 0 and 1. So what I have done here is that necessarily the whole neural network is same, but I just changed the last layer of this neural network, where I take into consideration only one neuron, and I kept my activation function as sigmoid. Cool. So yeah, so I kept my activation function as sigmoid. The optimizers are the same. The loss function I kept it as binary cross entropy, and our matrix is accuracy. So yeah, let's train our model and see what it. So we compiled our model. Now let's train. So it's pretty much the same. We have a X train, Y train, and we train it for 5 epochs. Just take into consideration we have activation function as sigmoid here. So you see you see for binary classification we have a pretty much a better accuracy score here. We have 98% accurate model here. So let's let's predict a model. You see, so suppose we have our X train, we put in -2 here. It's you see it's close to 1, right? So, and you see our Y train is also 1. For instance, if I take instead of -2, let me take 2. You see it's close to 0. It's necessarily 2.26 into 10 to the power -5, and so here it should be 0, I guess. Yeah, it's 0. So you see what sigmoid does. It converts your answer between 0 and 1, and when your answer is greater than 0.5, when your answer is greater than 0.5, you are getting the answer as 1, and if your answer is greater than 0, then it's giving you the answer as 0. Let's test it out with any other number. Suppose consider -1, the last. So we are getting our the answer as 0.99, let's see our Y train. So you see it is 1. So you see how, see what difference that we are getting here. You see, our, if our model is close to 1, then we are getting it as 1. If it's less than 0.5 or close to 0, we are getting our our prediction as 0. So we can we can just round it off and answer, and we can get our our results. So that was the practical demonstration. Let's move on to our next thing. Okay. Okay. So now we come to this is the final part of our PPT. So we will look what are teachable machines. So teachable machine is it's a cool website where you can perform 3 kinds of machine learning tasks, very cool machine learning tasks, like pose estimation, image classification, and they have some audio models. It's made with TensorFlow.js. It enables you to train your models, and you can download those models, and you can use it in your projects. And that's pretty cool. Suppose if you are not into the AI thing, but you want to produce some results with AI. You need to implement AI, but you don't know how to implement, how to build up neural networks, and how to build accurate models. Then just for the sake of performing a simple AI task, you can use this particular website. Now let's see what it is. So it's teachable machine with google.com. So it's made with these tech stack. So let's get started, and just so let me just demonstrate you the image project. Now this is really cool. Let me just demonstrate you this to you. Okay, so suppose here I am, and suppose if I want to classify between this sign and this sign. Cool. So let me take some sample data from my webcam and just train my model. Suppose I'm keeping my hand like this. Cool. So I keep my hand like this, like this. So suppose we have 80 image samples of this scissors. Okay, now let me add a different class to it. So suppose let me keep my hand like this, rock sign. Cool. Okay, so we have enough image samples. Now what we do is that we put our model into training. It will take some time. In the meantime, if you have any questions, you can ask me right now. Hello. Okay, cool. Let's wait for this model to train. It also provides you some hyperparameters to play with, so like suppose batch sizes, learning rates, and inbox. Let's wait for this.
Hello.
Yeah, hello.
Yeah.
Yeah.
Can you just elaborate on the part when how to use the activation functions like the sigmoid and the difference between sigmoid and uh,
And
the one
Softmax.
you use. Yeah, yeah, sigmoid
Yeah, sure,
software.
sure. Okay,
Yeah.
so okay. I'll get back to your question after after this demonstration. So yeah, so look at this model. Suppose if I put my hand like this, we get class 1 as scissors. Say it's accurate. Suppose if I do like this, say it's class 2. Now it's performing its task pretty much well. It's like it might be lagging on your screencast, because sharing this screen, it's also lagging for me. But when you do the same on your PC, then it won't be the same. Cool. Just for the demonstration purposes, I'm showing this to you. You see. So now what you can do is you can just export this model, and it gives you 3 options. You can export it for your JavaScript, for your Python. You can just export it as h5 module, and then you can just pretty much paste this code, and your model will be working fine. And then you can use this in your Android or Flutter application, or your Java application or anything. So yeah, this was trainable machine. So we have many more teachable machine. I'm sorry. So you have many more projects to play with. You can also see pose estimation. You can see audio projects. So you can go to this particular website, and you can play with these models. Okay. So yeah. So that brings us to the end of this presentation. So thank you for attending this presentation. So yeah, now it comes to the question and answer. Yeah, so the answer to that question is, what is the difference between sigmoid and softmax, right? Okay. Yeah, can you repeat your question?
Yeah, the difference between the activation function sigmoid and softmax, and why we use it and when we need to use it.
Okay, so the sigmoid activation function is necessarily used when we have a binary classification task. So whenever you have a binary classification task, then it's better to use sigmoid activation function. And in case because it's computationally less expensive, and yeah, it solves your problem pretty much well. But suppose if you have more than 2 classes, then it's better to use softmax activation function, because sigmoid just gives you a number between 0 and 1, and it's not necessary. It is not a probability. It's just a number between 0 and 1. It's not a probability. It has just an equation. It puts that your output into an equation, and gives you a number between 0 and 1. Whereas softmax activation function gives you the probability of every particular class in the output layer. I think that is the answer to your question, I guess.
Yeah, I got it.
Any more questions? If you can't switch on your mic, you can just type it out into your into chat box.
I guess if we have time, we can talk about the hyperparameter tuning part.
Hyperparameter tuning. Okay.
If there are no
Okay, cool, no problem. I'll just show you a simple hyperparameter tuning problem, like like in the previous notebook. Yeah, sure. I can share the notebook. I'll give you the links to the notebook, or what I'll do is that I'll I'll post this whole notebook, and the slides on my GitHub repo, and I'll share it to you. That's not a problem. Okay, let's do this. Let's if you have any questions, you are free to ask. I can help you. It can be very silly question. That's not a problem.
Hello.
Yeah. Hello.
What are the minimum prerequisites to learn machine learning? Like I couldn't get the whole idea while watching the seminar.
Okay. What do you want to? What exactly you want to know?
I want to know the basic prerequisites. Like I need to learn this thing before starting with machine learning and all.
Oh, okay. If you
I know
want,
basic Python.
basic Python. Okay, so before getting into machine learning, you need to learn that how you can work with data. How much insights can you? Yeah, I showed you one slide from okay, I showed you one slide from in my whole presentation where I said that gather data and then explore the data and then prepare your data and then comes the model building process. So it all starts with doing that exploring part, getting insights in what your data speaks. And then once you get what your data speaks, then you can just dive into just preparing your data to put it this into your neural network or into your any traditional machine learning model. So how to get started. You can get started with if you want to get into the core machine learning, then you can start with Andrew Ng's Stanford course. It will guide you pretty much well. It will give you all the answers to your questions, because it will teach you all the necessary machine learning algorithms. It will teach you that how small things can affect your models, and how pretty much everything. It will teach you everything. And then after that course, um you can go for the deep learning specialization. And pretty and every famous courses that are out there. And it's not that hard, to be very, believe me, it's not hard. It's just technical. It's a bit of mathematics, yeah, but yeah, it will help you a lot, I'm sure.
Thank you.
Yeah. Okay, so yeah, so as I said that we have trained this for 500 epochs, but you see that after 150 or 120, it's not increasing, right? It's of no use. And what you can do is that to save your resources, what you can do is that you can just change this particular thing, just 500 to something like suppose 120, and just this is also one kind of an hyperparameter tuning. And it helps you save your resources. That's it. It will prevent you from overfitting your models. So oh my god. Okay, this was supposed to be, what did I give the 120, right? So it should be 121. 120. See, at times it fails also. You see the loss funds, you see the loss, it's so high. The last time it was close to 40, now it's so this also tells us that it's 130 is not enough, 120 is not enough. You need to go further. You can you can go for this, say 160. And again we need to just compile a model, and then of 51 61. Now you see, if we would have trained till 130, then it would be better. So yeah, this is how it's done. Now you see our model is pretty much better, and our loss function is better. Yeah. So, and you can also see that the loss function is better than what we got that time. it only happens because all the weights that we take into consideration, it's been randomized. So maybe the random state of the weights that was taken into consideration when we were initializing this model, that also affected the answer of this particular training. So yeah, so you can play with this. You can play with this dense layer. You can change the number of units. You can just you can change your loss functions. You can use MAE, mean absolute error. You can use Huber loss, or maybe there are pretty much you can use gradient descent, stochastic gradient descent with momentum, RMS prop, any other optimization algorithm. You can play with the epoch size. You can you can have validation test split and pretty much everything that that can better your model. And after doing all these randomized tests, these experiments, you can come up with your ideal trained neural network model. Any more questions?
Hello.
Yeah, hello.
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 Yes. Can you explain about the ReLU batch normalization and max pool?
ReLU batch normalization and max pooling. I mean
Yes.
ReLU batch normalization and max pooling. Okay, fine. So first I'll start with ReLU, right? Okay. So
And when these are used.
what?
And when each of these are used.
Okay, fine. Okay, okay. So ReLU. So what ReLU is that ReLU is an activation function which takes in the input. It is like if your input is greater than 0, it will be x, was about the input itself, and if it's less than 0, it will be 0. Cool. So you can visualize the curve. It's a line that is necessarily x is equal to y that is passing through the origin, and when it comes to 0, it's just a flat curve, flat line. So yeah, that is the ReLU activation. That means that it ignores all the negative values and it only takes into consideration the positive values. Now batch normalization. What batch normalization is that why we do that? Okay, so to explain you batch normalization, it's basically suppose you have an let's visualize this graphically. Suppose you have an oval, right, and you have an circle. Suppose you are in the edge of the oval, right? It will take you more time from coming from one side to the other if it's an oval, and if you just squeeze that oval into a circle, then it might take you less time to reach from that particular point to the center. So what batch normalization does is that it helps push that oval into that circle, and that also betters your training process. Okay. If you could visualize that, it's better. Else you know normalization, if you know about normalization statistics and how it helps, it will also be useful. It will also be easier to correlate with it. And the third one is that what was the third one? ReLU batch normalization and
Max
what? Pardon?
pool.
Max pool layer. Okay, max pool layer. So max pool layer is necessarily, suppose we need to go into the convolution neural network. So suppose you have a matrix, suppose an image, suppose that image has a size 5 cross 5. Okay, so it has image is having a size 5 cross 5, and it's there you have a kernel. You have a concept of a kernel or a filter in case of a convolution neural network. Fine. So when that particular kernel is slided over that matrix, suppose you have an image of suppose size 28 cross 28, and you have a kernel of size suppose 3 cross 3. Now you slide that particular kernel on that convolution, and what max pooling does is that it, when you slide that small filter or that kernel over that 28 cross 28 image, it takes into consideration only the maximum value of that particular matrix in that 3 cross 3 region, and it transfers that maximum number from that particular that particular matrix position. Let me show you it. Let me explain you with a visual representation. अरे यार max pooling. Can you see this? Okay, this one is good. Okay, so here you have a image or a matrix of 4 cross 4, right? And here you have a kernel of 2 cross 2. So the kernel is moving from here to here, then going here and here. So in every step, it's taking into consideration only the maximum values. You see, here it's taking 4, here it's taking 8, here it's taking 6, and here it's taking 9. So this is the max pooling layer. The intuition behind max pooling layer is that, the intuition is that, if you are taking into consideration the maximum value, the intuition is that, you're taking into consideration the more valuable part of the image. That is the whole intuition behind max pooling layer, or the max pooling operation in neural networks. I guess your question is answered.
Yes, thank you.
Yeah. Any more questions? Okay, I think that there is. Okay, so that brings us to the end of this of this session. Before going, just fill up this form that's provided by the DeepLearning.AI. Filling up this form will give you it will help them better their online sessions, and it will also give you an opportunity to get a 50% off coupon code on every DeepLearning.AI AI courses. So just go and just fill this form very quickly. um, in the meantime, let's okay, so go and just fill up that form very quickly. And I'm also providing my link to my GitHub repo, where I'll be uploading all the slides and the notebooks. Do have a look of that also, and and to get the certificates, I'm giving you a link. Just fill up this form, and just then you will get the certificates. Oh, wait. In the meantime, if you have any questions, then you can ask me. The recording of the videos. Yeah, sure. I'll post it on YouTube, and I'll set